Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we'll discuss about matching, clique and independent set. In our previous classes, we clearly discussed some of the basic concepts on graph. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, it's very easy class to understand. Matching. When we say it as a matching is a set of edges. We take a set of edges from the graph, that set of edges that do not share a common vertex. Whatever the set of edges, subset of edges we picked that do not share the common vertex. You take any pair of the edges, you should not have this common vertex. That is what we need to understand. With example, you are going to understand it better. Let's take this graph A, B, C, D, E. We are taking a set of edges A, B, D, C. So AB is an edge, DC is an edge. You take two edges. These two edges are not sharing a common vertex. There is no common vertex in between these two. So it is a matching. We call it as a matching. Let's take one more example. ABAD. Here it is sharing a common vertex. A is common. ABAD. There is a common vertex. So it is not a matching. That is what the definition of matching says. You take any number of edges for understanding purpose. Here we have taken only two edges. You can take three edges. You can take four edges. You take any pair of edges from this set. That pair should not have any common vertex. It should be satisfied for all the pairs that present in this set. Then only we call it as a matching. Next example you are going to understand much better. Now coming to the next example, when we are saying it as a perfect matching, matching in which all vertices are involved. If you select some set of edges, in that set of edges, if all the vertices are involved, then we say it as a perfect matching. Example, let's take this graph A, B, C, D, E, F. From this, if you take A, B, C, D, E, F, AB is an edge, CD is an edge, EF is an edge. You take any pair of edges from this, there is no common vertex. AB, CD, there is no common vertex. AB, EF, there is no common vertex. CD, EF, there is no common vertex. So it is a matching and it is covering all the vertices. A, B, C, D, E, F, A, B, C, D, E, F. That's why it is called it as perfect matching. We are having one more pair also, B, E, C, D, A, F. B, E, C, D, A, F. This is also a perfect matching. You can have any number of sets like this. So that is what we call it as perfect matching. Now coming to the next definition, clique. A subset of vertices. You take a graph. From that graph, you need to pick some subset of vertices. Is said to be a clique. When we say it as a clique is, if we take any pair of vertices in the subset, whatever the subset you selected, from that selected subset, you take any pair of vertices. We should have an edge between those two pair of vertices. Then we say it as a clique. With example, you are going to understand it better. Let's take this diagram, graph A, B, C, D, E, F, G. We are taking subset of a pair of vertices, C, D, G. C, D, G is a pair of vertices. We say it as a clique of size 3. Yes, 3 vertices selected, C, D, G. You take any pair of vertices, C, D, there is an edge. C, G, there is an edge. DG, there is an edge. You take any pair of vertices from this subset, you should have an edge. Then we say that subset of vertices, we call it as an clique. Clique of size 3. Similarly, A, B, C, D is a subset of vertices which is having, you take any pair of vertices, AB, there is an edge. AC, AD, CD, DC, DB. You take any pair of vertices, we are having an edge between those two vertices. Then we say it as A, B, C, D is a clique of size 4. That is what the definition of cliques. Now coming to the next one, independent set. Simply we call it as independent vertex set. A subset of vertices are called independent set. So from the given graph, we have to pick some subset of vertices. That subset of vertices we call it as independent set. When we say it as independent set, no two vertices are adjacent. You take any pair of vertices from the subset we selected, those two vertices should not be adjacent. What is meant by adjacent? We already discussed in our previous basics of the graph. Let's say this is the graph. A, B, C, D, E, F, G, H. A, H, C is a subset of vertices in which you take any pair A, H. Is there an edge between them? If there is an edge, then we say it as A, H are adjacent. There is no edge. A, C, no edge. H, C, no edge. So they are not adjacent. You take any pair of vertices from this, you should not have they should not be adjacent. Means you should not have an edge between those two. Then this set we call it as independent set. Now coming to the maximal independent set. What do you mean that maximal independent set? See, this should be understood properly. AGC. AGC. This is maximal independent set. Why we call it as maximal independent set? AGC. If you are not supposed to add any of the vertices from the graph other than AGC. If you add E, it is not allowed because GE is having edge. If you add B, it is not allowed because BC is having an edge because we added AGC. If you add D, C and D are adjacent. If you add F, H and F are, C and F are adjacent. So when we say it as maximal independent set, no other vertex from graph G can be added. Then this set we call it as maximal independent set. Similarly, we are having EF. See here, EF. This is also maximal independent set. You are not supposed to add any of the vertex to the set EF. Because if you add A adjacent, B adjacent, C adjacent, D adjacent, G adjacent, H adjacent. So both of them are maximal independent set. But what we need to understand is maximum independent set. Out of this maximal independent sets, which one is having highest number of vertices? First one is having the highest number of vertices. That we call it as maximum vertex set from the maximal independent sets. We call it as maximum independent set. So these are the definitions we need to understand from the graph theory. And if you want to understand the coding part, these discussions will be made in our design and analysis of algorithms playlist. Please watch that playlist, and if you want to understand the coding. Hope you understand this concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.